sorry for that volume. So before I get into the presentation, I would like to just hello. I request everybody to keep their phones or their laptops or their desktops on mute, because otherwise it will be a big challenge. We won't be able to hear anything. So I request everybody to keep on mute, and also their videos closed. That would be a very kind of you for all of us. I can still hear some background noises, and I'm sure it is not from mine. So I request everybody to please close that. Thank you. So let me just share about PRIYABRATA. So Professor Dr. PRIYABRATA ADHIKARY is on the screen. He's a BE Bachelor of Engineering from Jadavpur University and a mechanical engineer from Jadavpur University again. And he is a PhD of engineering in Jadavpur University. PRIYABRATA, you can just set up your slides from the second slide. The presentation was second slide till the time I complete your introduction. And the professional is presently is a professor of mechanical at New Horizon College of Engineering, Bangalore, the top 4 colleges in Bangalore. He is also an HVAC and R consultant at New Horizon College of Engineering, Bangalore. And he's a speaker he's within world top 10 researcher in turbo machines. He's a global scholar, and he also is credited with several best research paper awards, NIT, IIT, and OWP. 80 publications to his credit. His academic experience over 8 years in Amity University, Kolkata previously, and then New Horizon College of Engineering, Bangalore. And he has also got industry experience of more than 8 years in India as well as in Oman, in various companies like Blue Star Limited, Carrier Air Conditioning Refrigeration Limited, PECLC Oman, ET Engineering, and Rhinak India. I remember those days when we used to have really fights because of he was my competitor once upon a time. So those were the good old days. So without further ado, I'd request you to please share your screen, and let us start with the presentation. Yeah, your sheet is visible. I would also like to share before he starts. This is our first refrigeration program for society year 2020-2021 in our chapter. A lot of noise at the back. We've got the topic. It's green cold chain, the key to minimize loss and maximize profit. So the stage is all yours, PRIYABRATA. Please take it away. Thank you.
Thank you, Mr. Pramodji Banerjee, President, Shri Kolkata chapter. Thank you, Refrigeration Chair, Mr. Shankhu Bhattacharya, and all my beloved CWC Kolkata Ishray chapter members. I am honored to get this opportunity to present a webinar on behalf of Kolkata Ishray chapter. My presentation is on refrigeration air conditioning. It is covering mostly industrial things, but at the same time, I know that many college students or budding engineers will also join. So I have tried to keep some technical calculation part in the webinar. So I will request the budding engineers, the student members, to have a pen, paper, and a calculator handy if possible. Because once you do in your hand, do the calculation in calculator, you will get lot of confidence. I want this webinar to be really effective for all of you. So here we start. Now, my first question is, what is the requirement of refrigeration? From this first slide, you can see that we have a huge amount of agricultural waste, horticultural waste, that is fruits, agricultural waste, that is vegetable and crops, poultry waste, that is chicken, mutton from the poultry, sausage, and not only food waste, we can also see there is a huge waste from the life-saving pharma industry, lot of life-saving drugs, lot of life-saving vaccines, as well as the bloods also get wasted due to improper handling and improper maintaining. So this is the cause of wastage. And what is the effect of wastage? From the need pyramid, we see the first level of need is physical need, that is air, oxygen, water, food, health. Now all these important parameters are directly related to refrigeration. My dear friends, I want to emphasize, I want to put light on the matter that refrigeration is equally or maybe greater than important as compared to air conditioning technology. But to be very frank, till date, the required focus is not there in India on refrigeration, and that's why we have the agricultural produce, but finally they are wasted. So what is the solution? The only solution we can refer to is a proper handling of this agricultural, horticultural produce, or the pharma industry, or the dairy industry produce, or blood banks, and so on. There is a pie chart showing worldwide the percentage of cold storages catering to various types of produce. The potato is shown in blue color and multi-purpose cold storage is shown in deep brown color. These two are the major portion of the global cold storage applications. Other than that, we also have dedicated fruit, vegetable, meat, fish, and dairy products, and other kind of products. These other products refer to the vaccines and the pharma products along with blood banks. This is a pictorial representation of Indian cold storage scenario. The blue color shows which states are having adequate cold storage facilities. The orange color shows the states have some cold storage facility but needs more, and the red color shows that cold storage facility is not at all there, so a huge infrastructure is highly needed for those states for the proper handling of produce. On the right hand side, I have given the Government of India departments which are facilitating in the cold storage or cold chain projects, namely National Horticulture Board, Agricultural Processed Food Products Export Development Authority, that is APEDA. Similarly, we have MPEDA, we have Ministry of Micro, Small and Medium Enterprises, and so on. Refrigeration, as I have shown in the left hand side, does not only limited to warehouse or cold storages. It also includes the transport refrigeration as well as the retail refrigeration till the material is reached to the end user. As I have shown, the warehouse, then transport, and then finally the end user retail, clubbing all the three, we actually call this as cold chain. And in India, we are having a big focus, like the other parts of the world, to develop a good, reliable cold chain to minimize the wastage and losses. As I have shown in the picture, the cold chain is having few components, starting from the farmer harvesting, then it will be transported to the nearest small trader having a small warehouse. From there, the transport refrigeration, it will go to the main warehouse and then to the market. Without proper cold chain, just below that, I have shown how much percentage of food loss is there due to unavailability of refrigeration system. My dear friends, the main point I want to highlight about cold chain and refrigeration is India is lacking awareness about the cold chain projects. As young budding engineers, you must make the people aware of these cold chain projects. You have to look for the man. The man means the person who is having money, authority, and need. The farmer, who is a man having money, authority, and need. So once you find out the man, you can guide the person to the right direction, how he can become an entrepreneur or he can become a cold chain service provider. Here, the information bulletin in the right hand side, published by Ministry of Agriculture and Farmer Welfare, shows the bullet points that who can apply: private industry, entrepreneurs, cooperatives, farmer groups, and PSUs. How to apply: the scheme demand driven, available all through the year. So all through the year, the person can apply for a cold storage project. Where to apply: all the horticultural mission, National Horticulture Board, which I have mentioned earlier. Through this government agencies, we can proceed for the cold chain or cold storage projects. Next slide, I will show the detailed process, how to proceed. So, Government of India is giving good amount of subsidy to process for the cold storage projects. We have to first create a detailed project report, DPR. with the help of a consultant, refrigeration consultant. Then the project DPR to be submitted to the National Bank. Then the loan will be sanctioned. Then the DPR plus sanctioned blank loan plus duly filled database. All these documents are needed for application of subsidy. Submit the documents to State Horticulture Mission or National Horticulture Board. Then state level executive committee will be inspecting. Then the project reports are vetted for technical compliance. In case it is required, project is marked to the Central Project Appraisal Committee also. And finally, the approval process comes along with the subsidy and all other facilities. So we have to make the farmer, the entrepreneur aware of this process so that in India we can generate a cold storage awareness or cold chain awareness very fast. As India is already focusing on this cold chain process, National Center for Cold Chain Development has already published a guideline and system standard manual which is available online. Anybody interested can download and go through the manual for further details. Now, my topic is green cold chain. In this particular guideline, it is also mentioned about the green cold chain part, that is to minimize the carbon footprint. Now, what does actually a cold chain means? The cold chain, as I have put the bullet points, compares of harvesting, routing, packaging, cooling, staging, transport process, storage process, distribution process, and finally the retail process. Now, again, I want to highlight on the point, the person, the entrepreneur, the businessman or the farmer who is investing in the cold chain process, there will be central government tax exemption, as I have mentioned here. So there are so much of motivation to develop this cold chain process as fast as possible in India, because on the second slide we have seen how much of food is wasted though it is produced. Now, what exactly a cold chain process means? It will be an organized solution for the food chain, starting from the pre-cooling after harvesting. Then it will be transported to the main warehouse. Then it will be kept in a particular temperature to reduce the decay and increase the shelf life. From there,
Yes.
from the main warehouse, it will be transported with the help of transport refrigeration to the end point of retailers, and from there the end user can get the product just as a fresh product. This is the only slide which is related to the students' syllabus. I hope there are few students in this particular webinar. My dear student, this is the very common vapor compression refrigeration cycle or vapor compression refrigeration system, comprising of the compressor, condenser, expansion valve, and evaporator. Now, the heart of the system is the compressor. There are various types of compressor in the market or in the HVAC industry: rotary compressor, reciprocating compressor, scroll compressor, centrifugal compressor, screw compressor. Just few sentences about the compressor working principle. Working principle is very widely expressed in the textbooks, but we have to understand one thing. People generally tell the students, mainly in the interview, the compressor pumps the refrigerant for the flow of refrigerant. Yes, that is one of the reason or one of the point, but what is the actual work of compressor? We have heard a thirsty crow story during our childhood. In that, the pot was having little amount of water. Now, the thirsty crow put some pebbles inside the pot to make the same amount of same quantity of water, but its level will be risen. The quantity of water will be same, but the level will be higher. The compressor is exactly doing the crow job. The amount of heat collected from the cooled space is at very low temperature.
But can
After
we take that from
compression,
Google, Ankit
as per
Kristin?
Charles' law, we know pressure is
Ankit
directly
Kristin, my
proportional
question
to
remains also
temperature.
same as
So with
Muthu.
the same
Can we take
heat
it from
content like
the Google
water,
or from the website?
as the
Is it
pressure
allowed?
is
Is it okay?
increased, the level of temperature is increased, so that the condenser can throw
Okay.
away the extra heat to a comparatively lower ambient air temperature. I hope this is clear. Now, coming to various types of compressor application, different types of compressors are applied for various types of load conditions. For very small load like domestic AC, we use rotary kind of compressor. Earlier, reciprocating compressor was widely used. For light commercial application, we go for scroll compressors. For comparatively higher application, we are going for screw compressor. And for a very large application, we go for a centrifugal compressor. Now, as I discussed the vapor compression refrigeration system, the same mother system is utilized in the warehouse, in the transport refrigeration, as well as in the retail endpoints. We can see the refrigerant, the vapor compression refrigeration system is shown in the left hand side cold storage room as the condensing unit. It is not only the condensing unit, it is also carrying the compressor, and the cold storage is made of puff panel polyurethane foam, which is an insulating material widely used nowadays. And inside the room, the evaporator coils are fitted. It is very much analogous to our domestic split air conditioners. We can imagine that the indoor unit will be in the cold storage room and the outdoor unit will be placed in the outdoor place, and both indoor and outdoor will be connected with copper piping, which will be definitely insulated. Coming to the transport refrigeration, the compressor is driven by the IC engine or the transporter engine, and the rest of the vapor compression cycle remains same. Now, whenever we are going for a cold chain, as per NCCD, there are guidelines. We have to follow the codes and references as mentioned in the NCCD handbook. I have given the tabular codes. The upper one is for the refrigeration system and the lower one is for the insulations. For the young engineers, those who are having heat transfer as a subject, can correlate with this particular drawing how the heat conduction equation is relevant with the insulation. So in this particular puff panel tabular column, we can see commercially available puff panels are at the size of 60 millimeter, 80 millimeter, 100 millimeter, 120 millimeter, 140 millimeter, 160 millimeter, 180 millimeter, and 200 millimeter. For general understanding, we may note that the positive temperature or cooler cold storages having plus temperature +2 to +8 degrees centigrade, we generally go for 60 to 80 millimeter panel thickness, and for 0 to -5 degree medium temperature cold storages, we go for 100 mm thickness, and for -18 and below, -25, -40, we go for 120 or more thickness of the puff panel. Now coming to green cold chain, renewable energy use. Young engineers, budding engineers, as I have told you, as per the guidelines of NCCD, they have clearly mentioned the cold chain, if it is possible to be driven by the renewable energy sources. The main limitation of the renewable energy is very much site specific. So the solar energy is the only energy which is widely available across India. So I have given a brief idea about the renewable energy PV solar cells which can be used for this cold chain application. This is the guideline which I have spoke about, mentioned by the NCCD manual. Now, whenever we are having a PV solar system power generation unit, it will consist of mainly 4 components. First is the solar panel DC power. Second is the battery as power accumulator. Third is inverter, which will convert the DC power into AC power. And finally, the end user or the appliances. Now, appliance for our application will be the cold storage.
Okay, bye.
Now I will give
Bye.
a very brief idea to the refrigeration budding engineers about the other three parts, that is DC power panels, inverter and battery. Now from this slide, we are talking about the first component, that is the solar panels. The solar panels, a typical solar panel specification is given here. Maximum power 250 watt, open circuit voltage 37.5 voltage, optimum operating voltage 30.1, optimum operating current 8.32, and so on. Now, whenever we are going for this solar, if it is a small quantity, generally the price of the solar panel will be varying from 25 to 30 rupees per watt. And if we are going for a large quantity, definitely for our cold storage and cold chain application, it will be a large quantity. So typical price of panel will be 20 to 25 rupees per watt. The solar panels available in the market are of various size, I have mentioned. It starts from as small as 1 watt, 5 watt, 10 watt, 50 watt, 100 watt, 250 watt, 300 watt panels, and so on. Now, coming to the batteries, very important. The second part, the batteries are available in the market as 2 volt, 4 volt, 6 volt, 12 volt, and we can add them in series to get higher voltage capacities. Two important ratings of the batteries are terminal voltage and charging capacity. I have given the basic formulas also, how to calculate the battery capacity before buying a battery. The batteries are mainly two types for solar application: lead acid battery and lithium ion battery. Now, for lead acid battery, for small battery size, the price will be 8 to 10 rupees per watt hour, and for lithium ion battery, it will be 17 to 20 rupees per watt hour. For larger battery size, lead acid battery will be around 7 to 8 rupees per watt hour, and lithium ion battery will be 13 to 16 rupees per watt hour. Based on my experience, I can tell that for cold storage kind of application, definitely we will go for lead acid type of battery. So our battery price should remain in 7 to 8 rupees per watt hour. The third component is the inverter that will convert the DC power to AC power, because most of the cold storage equipment manufacturers are having their equipments compatible to AC power. So first we have to understand the role of inverter. It gives AC power output and extract maximum power from the panel. It manages the battery and convert DC to AC power. Efficiency of the inverter, typically available market inverters are 80 to 90%, but if we are going for good inverter, we can go up to 95% of the efficiency. Typical inverter rating: 1 kVA, 2 kVA, 3 kVA, 5 kVA, and so on. The cost of inverter, again for your idea, rupees 4 to 8. per watt for average kind of inverter. And if we are going for a very good quality inverter, cost will be around 8 to 15 rupees per watt. Now, I just want to tell you the first or second slide I have shown how a non-refrigerated value chain works. That is a normal way the farmer is harvesting the product and they are directly selling in the market. But if we are going for a cold chain, then there will be difference. There will be pre-cooling, then it will be a bulk storage, then there will be retail cooling. Finally, it will be coming to the end user and it will be stored in household refrigerator and it will be consumed. Just a small definition of 4 types of equipments or parts. Bulk cooling refers to storage of large quantity of produce. Retail cooling, that is the retail shops or the end user point where the customer will buy the product. Domestic cooling or domestic refrigerators, and transport refrigeration, which connects the bulk cooling and retail cooling. My dear student or my dear colleagues, when you are working as a refrigeration engineer, basically you are doctor of the system. You are the refrigeration expert. So before giving the solution, as a physician or a doctor wants to check the blood test, the X-ray report. Similarly, hello.
মিউট হলে তো এটা তো কালো রঙের আসছে, এটা কাটা হয়ে যাচ্ছে, নাহলে তো যেমন ভিডিও কাটিং আছে।
Hello.
Sorry for the interruption, Priyabrata. Please go ahead. I think there was somebody who was unmuted his mic. I have muted him.
Okay. As Mr. Banerjee, my voice is clearly audible. I am speaking little slow because there is a lag.
You're absolutely clear. If you can speak a little fast also, there's no challenge. Your voice is absolutely clear.
Okay, okay. Thank you so much. Now, what I am trying to tell, as an expert, as a refrigeration expert, basically you will be a doctor of the refrigeration system. So as the doctor is asking for blood test reports and X-ray reports, similarly, the refrigeration engineer or the expert has to understand the product features or the product characteristics before giving a optimum solution. For having the idea of various products, I have given a brief table showing what are the relative perishability, ideal temperature range, ideal relative humidity, and ideal atmospheric composition. For fruits and vegetables, we can see that it can achieve maximum shelf life, and ideal temperature for keeping is 0 degree to 2 degree centigrade for non-chilling sensitive crops, and for chilling sensitive crops it will be little higher, 5 degree onwards. Ideal relative humidity will be around 70%. For leafy vegetable like cabbage, it can go up to 85 to 90%. And ideal atmospheric temperature, oxygen should be removed from the storage atmosphere and carbon dioxide content to be decreased so that the metabolic process can be controlled. For dairy products, highly perishability, fresh milk, maximum storage life up to 2 weeks. The ideal temperature for keeping the product 4 degrees centigrade for fresh milk and around 10 degrees centigrade for cheese, butter and other dairy product, but not ice cream. Ice cream is coming under frozen products. Other than ice cream, all other dairy products can be at a range of 4 degree to 10 degrees centigrade. Low to medium relative humidity to avoid microbial growth. For ethylene sensitive products, avoid ethylene buildup to slow the ripening. The poultry and meat and fish, along with this, we can also think of the ice cream, because we generally store them at a very low temperature for long time. For short time they are stored at -2 degree, but for long time storage, while export is done, it is stored at -18 to -25 degrees centigrade with medium to high kind of relative humidity. For meat it is 85 to 95%, for fish it is 90%, and atmospheric composition is of low relevance for storage of most of the products, because they are already pre-processed and sealed and packed. As we have discussed about the various types of products to be stored, now we are discussing about various types of equipments which are used for the refrigeration system. The most common and popular we have already discussed, vapor compression cycle. Other than that, there is vapor absorption system, evaporative cooling system and ice making system. All these things are important, but in India mostly vapor compression cycle refrigeration systems are majorly used, whether it is a cold storage application or it is a transport refrigeration application. I'm going a little faster because I'm lagging time. Popular refrigerants for refrigeration application, I have mentioned R404A, widely used in India. For plus temperature, R134A, widely used. Some places R507A is also, 407C is also used. Now, as a refrigeration engineer, we have to optimize the design. The engineer's work is always to design for optimum, not minimum, not maximum. So while we are designing an optimization, the main components in all the stage, that is bulk storage, retail storage, domestic storage as well as transport, we have to optimize the heat exchanger, we have to optimize the compressor capacity, we have to optimize various other parts, thermal expansion valve. In this connect, I can also tell you that shortly in Indian market, the inverter kind of technology is going to launch. Already refrigeration companies are having rack system, which is very much analogous to VRF systems, but rack systems can handle multi-purpose cold storages. So different chambers having different kind of temperature, the rack system can handle. So this is a very good example of system designing optimization. Again, what are the phases of cold chain? The small holder or farmer, the field of activity will be post harvest cooling, then transport refrigeration, then temperature management by the trader. That is, there will be a main cold storage, there will be a packaging and grading storage. Finally, through transport refrigeration, it will reach the supermarket or retailer and to the end customer, where it will be stored in the domestic refrigerator. The Green cold storage features, I have given a summary. The location should be near the railway or road terminals, eco-friendly plant layouts, efficient building design, effective thermal insulation, eco-friendly energy efficient refrigeration system and refrigerants, waste heat recovery system, very important, effective control of VFDs systems, energy efficient lighting, electrical system, natural ventilation wherever required, noise control, fire safety, use of renewable energy we discussed already, minimum water consumption and recycling, rainwater harvesting, energy saving such as accessories such as air curtains, strip curtains, etc., and operational practice so that we have a greener tomorrow. I can just mention that there is an official inauguration of Subrawal Food Industries Private Limited in Haryana. They claim that they have the first green cold storage in the country. As I told you, like a doctor, the refrigeration expert has to understand the product characteristics before giving an optimum solution to the client. Now, where we will get these data? Dear colleagues, many refrigeration engineering manuals are available online. One of the popular refrigeration engineering manual is Russell, which is freely available in website. So if we download that book, for each and every product, as we see the characteristics and their temperature, specific heat, latent heat, relative humidity, everything is documented in those manuals. So with the help of those manuals, we can easily give a optimum solution to the client or the end user or the businessman or the entrepreneur. Now coming to the design part, let us take a arbitrary calculation, a model cold room calculation. Students and budding engineers, I already told you to have a pen and paper and a calculator handy. So let us consider a simplified example of cooling load calculation for a cold room. Let us take the dimension as 5 meter, 6 meter by 5 meter length and width and 4 meter height. Let us assume ambient is 30 degrees centigrade and 50% RH, and the internal air will be 1 degree with 95% RH. The wall, roof and floor all are insulated with 80 millimeter thickness polyurethane foam having U factor 0.28. This U value you will be getting from the engineering manual handbooks for various insulations. The ground temperature is 10 degree. So just to note that manufacturer should tell you about the U value of the insulation. So you can take from any engineering manual handbook. Now, first to calculate the transmission load, there is a difference with the normal HVAC heat load, cooling load calculation. In air conditioning load calculation, we have wall, we have window, but for cold storage, we only have same wall that is made of polyurethane foam. So our calculation will be only having same U value of 0.28. And this is the main formula for calculating the transmission load. So please calculate the transmission load taking U value as 0.28, area based on 6 meter, 5 meter into 4 meter, temperature out minus temperature in, 30 degree and 1 degree, but in case of floor it will be 10 degree and 1 degree. So coming to the calculation, I want you people, I am giving 1 minute, please do the calculation on your hand. So we can see we are getting wall and roof total heat 22 kilowatt hour per day, and for floor we are getting 1.8 kilowatt hour per day, because for wall and roof 30 degree minus 1 degree, whereas for floor it is 10 degree minus 1 degree. Now coming to product load. So finally the total load will be the wall, roof and the floor. So total transmission load is 23.8 kilowatt hour per day. Now coming to product load exchange, which is exchange. There are 4,000 kg of new apple arriving each day at a temperature of 5 degrees centigrade, and the apple specific heat is 3.65 kilojoule per kg. This data again we will get from the refrigeration handbook. So we will take this formula, Q is equal to MCP, temperature in minus temperature stored. Now temperature in 5 degree, temperature stored is 1 degree. So we will get the product load as 16 kilowatt hour per day. I'm going a little slow. I'm giving 1 minute time for the calculations so that you get more confidence. Those who are students, participants. Coming to the product respiration load, we have the formula at the bottom: mass into respiratory load per 3600. Now there will be total 20,000 kg of apples. So the respiratory load is 1.9 kilojoule per kg. We will get from the handbook, and 3600 is to convert kilojoule to kilowatt hour. So the total load we are getting as 10.5 kilowatt hour per day. Now coming to internal heat load of people, those who are working inside the cold storage. Let us take 2 people working for 4 hours. So this is the formula, Q equal to people into time into heat, and they are giving of 270 watt of heat per hour inside. Again, this data is available from the engineering handbook. So once we calculate, we get 2.16 kilowatt hour per day. Now coming to the internal heat load lighting, lamp into time into wattage divided by 1000 to convert watt to kilowatt. Let us have 3 lamps of 100 watts running 4 hours per day. So directly from this formula we can get 1.2 kilowatt per day. Equipment load, evaporator, motor, because the fan motor inside the cold storage will generate heat. So we have fan into time of operation into wattage of the fan divided by 1000 to convert watt into kilowatt. So 3 fans, 14 hours it is working, and 200 watt each fan. So with the simple formula we get around 8.4 kilowatt hour per day. Similarly, we have defrost fan formula, power into time into cycle into efficiency. So power of the fan is 1.2 kilowatt. It is running for half an hour, 3 cycles, and efficiency is 30%. So similarly, we are getting 0.54 kilowatt per day. So the total equipment load is then, we are just adding. Coming to infiltration load, the simple formula, air change into volume into energy, temperature out minus temperature in divided by 3600. So temperature out is 30 degree ambient, temperature inside is 1 degree. Energy we will get from the handbook. The volume of the room 5 into 6 into 4, and 5 air change we are taking here from the handbook. So we are getting 9.67 kilowatt hour per day. Finally, all the loads are added and we are getting a total load of 72.27 kilowatt hour per day. Frankly speaking, if your calculation is proper, I do not support this safety factor. But anyway, you don't know what is the actual situation and how the end user will use. They will tell you about minimum door opening, but maximum time they will keep the door open. So to be at safer side, we have to take a safety factor of 1.2. Otherwise, we will get call and complaints from the customer that cold storage is having some problem. So taking 1.2 safety factor, we are getting 86.7 kilowatt hour per day. Based on that, we have to do the selection of refrigeration equipment. Now, whatever calculation you have done in pen and paper, my dear colleagues, in practice, this Russell Engineering Refrigeration Handbook is having a refrigeration box load calculation form, which you can definitely make in an Excel sheet, very simple form. And in this manner, the box load is calculated. It is made in this way so that by mistake, not a single heat source is omitted, because one single heat source omission can cost a big amount for a big cold storage. And this engineering handbook is online available in this particular web address. I have given the link, so you can take a photo of that and you can download that. It is freely available. Now I have given some screenshots of the data that are available in the handbook for various kinds of products and their characteristic value. Pressure temperature chart of 404A. As I told you, refrigeration systems are mostly using 404A. The minimum and maximum temperature, the minimum and maximum air change guideline as per the handbook. For vegetables, minimum is 30, maximum 60. Meat storage 30 to 50. Holding cooler 40 to 80. Holding freezer again 40 to 80. Blast freezer 150 to 250. Now you see, when it is a blast freezer, you have to cool down the temperature very fast. So your air circulation rate will be very high. So air change is very high. And when it is only a storage, the air change or the air circulation is very low. And as a refrigeration engineer, for a good designing, you have to visit the site and you have to ensure a proper location of the evaporator units, because if the evaporator units are not properly placed, the air circulation is not proper, the cold storage will end up in huge loss, because the material far away from the evaporators will not get cooled properly and will be wasted. So placement of evaporator coils inside the cold storage is equally important, and they need expert suggestions for the clients. Coming to a brief design idea of transport refrigeration, when we are designing or sizing or selecting a transport refrigeration unit, we are taking this simple formula where P equal to quantity of heat in watts penetrating through the body of the wall of the refrigeration application. K is the isothermal factor of the body. MS is mean body surface area. In T is the minimum temperature in centigrade to be obtained inside. External T is the maximum outside temperature, and 1.75, this is minimum ATP safety factor. Now, what is ATP? ATP is a treaty for European Union, and across the world we are also following that. K, again the insulating material. MS, we have to calculate from the body surface area. Now, internal T and external T, we have a map in the handbooks available. I can show you. This is for the maximum temperature across the world, and similarly this is the minimum temperature across the world. So all these value we can put, and we can do the transport refrigeration sizing and selection. This is a sample transport refrigeration selection chart from a manufacturer, just for your understanding. Again, as a refrigeration expert, you have to be very careful and guiding the client or the end user or the entrepreneur in all steps how to get optimum performance for the entire green cold chain. Thank you. Any questions?
Thank you, Dr. Priyabrata. It's a very informative discussion, I must say, and a good insight as to how we should plan. I remember when I was working in refrigeration industry, there was a saying that if India produces so much that if the produce can be properly saved through effective cold chain, no citizen of the country would go hungry. I believe that proves by your presentation also. We waste food not only by choice but by also by our ineffective cold chain technology. So, if you can just share your email ID so that I can just write it down for the benefit of all. In the chat box, can you share your present email ID, please?
Yeah, I'm writing.
Okay, great. Till that time, if there is any questions, I would request please unmute your mic and shoot. Anybody? Okay, so I believe your way of presenting has been understood by a lot of people, and it has been very clear to everybody. So if there are any questions, the email ID is already mentioned. So participants, you can get in touch with Dr. Priyabrata for further discussions. And I think if there are no questions, then We may have to call it a day or call it a night. Uh, Thank you all. And there's one request coming from Suman Reddy. Oh, there's some questions. Okay, people have realized. 1 minute. 1 second, Mr. Prabhu. So one question from Subhan Reddy. I request one more webinar on AC load heat calculation. Heat load calculation. Dr. Priyabrata.
Okay, can be done.
So you have got a new subject to talk about for your cooking.
My pleasure.
So next question is from one more. What is the minimum fresh air to consider in cold rooms, particularly fish and meat?
This question is a little confusion with the cooling load calculation of AC because as you know, Mr. Banerjee, that fresh air load for cold storage we doesn't take separately. We only take that door opening and door closing because inside we try to minimize the oxygen level so that the metabolism rate decreases. So
Yeah,
I
true.
will request the participant who asked this question, if he can go through the engineering manual, the things will be more clear. There are few little understanding difference with AC load calculation and refrigeration load calculation.
Very true, Dr. Prabhu, because we don't require much of fresh air inside a cold store. Otherwise, things will go bad.
Correct.
So and we don't want any humans inside, frankly.
Correct.
So I remember one of the examples I want to share when I was working with Blue Star and they were looking for mortuary chambers. You have also worked with Blue Star, you would be knowing that. So they were mentioning how much pressure is required for mortuary chambers. That was the most,
Correct.
I would say,
Correct.
illogical
Correct.
question ever heard. Okay, any other questions? Let me just check. Okay, there are some more. Just let me just make it big. Okay, AC heat load, people have asked you why. I
So I
think
think the simple calculation was attracting those participants, mainly students, I think.
yeah, there's a question which has come from Mr. Ronak Bhattacharya. Why are we not use vapor absorption system commonly?
Mr. Ronak, it is a good question. First of all, we have to understand where we use vapor absorption, where we are generating steam for other purpose. There we are not using an electrical compressor. So if you have to build up a steam generating station for refrigeration, that will not be a feasible idea. And in 99% of the cases, the cold storage guy or the cold storage businessman is not having a steam requirement. He's a cold guy, not a hot guy.
Yeah,
So,
true.
so
Okay.
as he is not having a steam requirement, so he has to go for a vapor compression system. Steam requirement, I mean, if he is having a textile company where steam is required or a paper mill where steam is required, he is generating steam for other purpose, abundant steam, there he may not go for a electrical compressor or vapor compression system. I think I am clear in short.
Yeah. There's one more question regarding door panel sizes. What should be the door panel sizes? I think 3x6.
Very simple. Very simple. In fact, our president can also reply on this. The thickness of the wall panel will be the thickness of the door panel, because nowadays they are using flush type door. So the thickness of the panel, wall panel, will be the thickness of the door panel.
And the sizes would depend as for the effectivity. If there's a tube
Yeah,
door,
yeah,
it
correct,
will be a
correct,
smaller size, 3 by 3. Or if it's a bigger door, then it will be a
correct.
3 by 6 or a double door, whatever.
So it is a
Okay.
cold room, it's a small door. If it is a warehouse, it is a big door, sliding kind of. So it depends on the application.
Yeah, there is one more question from Mr. Pankaj Gupta. Is there any type of precautions considering bacterial and fungal infection during the design?
We have to take care of the water air entry, that is door opening, because more the oxygen is inside, the metabolism rate will increase and it should start decaying. So that is the only thing, and proper temperature maintaining, proper air circulation through the crates is more important.
Right. And could we share your presentation to the participants, those who want to it?
Yeah, I have no problem, but you just check any disclaimer or something is there. Otherwise, I have no problem. You can share, because everything has been taken from the Russell engineering manual, and I told clearly that it is freely available, so they can download that. Others are few pictures only.
Yeah. So,
Yeah, it's up to you. Means if you wish, you can share.
so if there is anybody who wants
Because
to get the presentation, this
because my
is
message is from Albert Einstein. Once you stop learning, you start dying. So I cannot tell no.
correct. So I have shared my email ID. Those who want it can please put in a mail to my email ID. I can then separately send you. There's one question from Mr. Sujay. From Mr. Sujay, the
Okay.
ongoing coronavirus is due to lack of cold storage management. Uh,
Cold
leakage.
storage has nothing to do. Means
Yeah,
cold storage. Actually, we are thankful to cold storage, because this Moore and Spencer and all these hypermarkets are open and they can give food because of the cold storages and cold chain only. So
absolutely.
So we should be thankful to the cold chain, and now we have to think of green cold chain.
Okay, the point Mr. Surya wanted to say was that virus came from a wet market. So how do we control the wet market? So he may be asking for cold storage management. But wet market is something completely different from cold storage system.
Yeah, yeah, yeah.
So there's one more question from Mr. Shankara. How do we control the supply chain due to the COVID-19?
We have to be more careful about the social distancing. Generally, the processed foods which are sold in the supermarkets or hypermarkets are packed, and the employees of the supermarket hypermarkets are also very much cautious. Recently I visited more Bangalore, so I saw. So yes, I think for if it is an organized cold chain, it is much safer than the normal market.
Right. So I believe there are no more questions. So rest can be taken care with an email to you. So thank you, participants. Thank you, Dr. Prabhupada. It was a very good presentation from the refrigeration side, and I'm sure people have enriched by your knowledge, and it's a
Thank you.
pleasure.
Thank you.
So there's one more question coming out at the last minute. What, which refrigerant is latest in the industry pertaining to greenhouse gas emission or minimum? That's a minimum
Uh,
greenhouse. Yes,
this is a highly what to say,
debatable.
debatable question, because see, greenhouse gas, carbon dioxide is one of the main greenhouse gas, but across the world there are various countries who are still using carbon dioxide refrigeration. Is well accepted. Till date in India, 404A, 134A, 507C, those are used. But let's see, we have to wait for some more to come.
Definitely, definitely. Thank you. So with this now I'll
Thank you.
close the meeting. Thank you all. It's a pleasure. Thank you.
Thank you.
Thank you,
Thank
sir.
you.
Thank you, sir.